Today we are going to see what do you mean by convolution. Whenever we have an LTI system, that is linear time invariant system, to which I am giving an input as x of n and I am getting an output of y of n, then the characteristics of the LTI system given as h of n, then I can write y of n as y of n equals to x of n convolved. Now this asterisk sign is very important because it is called as convolved with h of n. This is not into, this is convolved or convolution. This symbol is special symbol which is called as convolution symbol. Now how this actually can be expressed as y of n equals to summation k is equal to minus infinity to plus infinity x of k h of n minus k. I can see that the simple expression x of n asterisk h of n is written as this. So this simple instruction or expression is this formula. So it is not into but convolution, and this is called as a convolution formula, or in some text it is referred to as convolution sum. So various texts uses various notions. Some texts call this as convolution formula, some text call this as convolution sum, and some text refer to this as convolution. All are one and the same. Now there are basically two types of convolution. One, so I write convolution. There are basically two types of convolution. One is linear convolution and the other one is circular convolution. What is the basic difference between linear convolution and circular convolution? Linear convolution is for aperiodic signals. It is mandatory aperiodic signals. If the signals are periodic, then we go for circular convolution. So if the signals are periodic signals, then we will go for circular convolution, and if we have aperiodic signals, then we will go for linear convolution. What do you mean by periodic signals? Periodic signals are those signals which repeat themselves after certain period. I will just draw one example so that you will understand. Example, if I have a signal which is like this, say the amplitude is going on 1, 2, 3, 4, x axis I have n, and this is n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. Then after 3 the signal repeat itself as 1, 2 and so on. So this is n is equal to 4, n is equal to 5. So after 3 the signal repeats and becomes 1 again, 2 and 3. Similarly, if I go on the other side of the, that is minus n, then for minus 1, minus 2, minus 3 and minus 4 the signal will be 1. Then here the last symbol, it will come as 4 for minus 1, then 3 at minus 2, then 2 at minus 3 and 1 at minus 4 and so on. This signal is called as a periodic signal which repeat itself after certain period. So this becomes our period. So what is the period of this signal? The period is normally denoted as capital N, which is equal to 4. So 4 is the period of the signal, that is after 4th sample. The first sample will be same as the 5th sample, or I can say is same as that of the first sample. So this is what a periodic signal is. If this type of signal are being applied to our system, then which type of convolution should I apply? I will apply circular convolution. Now Let us see one example of how to apply a convolution. So, I have a signal whose input is x of n as say 1, 2, 3, 4, and it has, or it is applied to a system with a response as 4, 4, 3, 2, and I wanted to find its output, that is y of n is equal to question mark. Graphically, I can see this signal as this system as an LTI system with its response as h of n, with the input given as x of n and the output is y of n, which is nothing but x of n convolved with h of n. Now, in the problem it is not mentioned that the signal is periodic. If it is not mentioned that the signal is periodic, by default the signal is aperiodic. So, these signals are aperiodic. So, given signals are aperiodic, therefore, we will use linear convolution. A linear convolution, as per the formula, is given as y of n equals to summation n goes from minus infinity to plus infinity, or we can say k equals to x of 1 is equal to minus infinity to plus infinity x of k h of n minus k. So, if you see x of n, our x of n goes as 1, 2, 3, 4. My n value starts from here as n is equal to 0, then n is equal to 1, then n is equal to 2, and this n is equal to 3. So, these are the n values. N is equal to 0 is the first by default value denoted by an arrow. The next instant is incremented by 1, that is n is equal to 1. Next is incremented by 2, n is equal to 2, and third is incremented by 3, so n is equal to 3. So, I have 0, 1, 2, 3 as the values of small n. Similar way, if I find h of n, then h of n is equal to 4, 4, 3, 2. So, if I take this as the initial value, then this becomes n is equal to 0, then 1, then 2, and then 3. So, again this becomes my n indexes. So, this is one n index, this is another n index, with this is the starting point. Now, let us incorporate this into the formula. So, for y of 0, that is I am putting n is equal to 0 in the previous formula, I get y of 0 is equal to summation k going from minus infinity to plus infinity x of k h of, now I am putting n 0, so it becomes 0 minus k. Therefore, I am getting as summation k is equal to minus infinity to plus infinity x of k h of minus k. That goes as now let us understand the significance of h of minus k. H of minus k is a mirror image signal. What do you mean by mirror image signal? So, h of minus k, that is a mirror image signal. We need to know the significance of this mirror image, or how to mirror a signal. So, I will draw a signal first with the indentation now k, and this is h of k, which is let us draw with another color. I say that this is my 4, 4, 3, 2. So, let us take this as the highest height of 4, and again I have at n is equal to 1 is just 4, and then I have 3 over here, and I have, let us say, 2 over here. So, n k goes from 0 1, 2, 3. So, I have 4 samples, n is equal to 0 or k is equal to 0, I have 4, k is equal to 1, I have 4 again, k is equal to 2, I have 3, and k is equal to 3, I have 2. How to mirror this signal? For mirroring this signal, k minus k, and I am drawing a signal called h of minus k. So, if I wanted to mirror this signal, what I will do is, I will keep a mirror on x is equal to or n is equal to 0 point. When I keep a mirror on n is equal to 0 point, and then shifting all of these samples on the other side. So, I will put sample number 4 on its place, because at n is equal to 0 I do not have to shift. I will shift this on the other side, that goes, this is my 0th point. Now, the first point is minus 1, which is also 4. So, this is 4, 4. I will mirror this on the other side, it goes as minus 2, which is at 3, and finally 3 goes over there as 2. So, what we did in mirroring? We kept a mirror over here at n is equal to 0. So, I do not have to shift this point and then moving all the sample values on the other side of the y axis. So, I kept n is equal to 0 instant as it is and shifted each instant. So, this will come on this side, this signal will come on this side, and the last instant will come at the end point this side. This is called as the mirror image. So, now I have my mirror image ready, I have my original signal ready. So, I have x of k ready as 1, 2, 3, 4. I have h of minus k ready, which is equal to, now I have to count it as 2, 3, 4, 4 with this as my origin, that is n is equal to 0. Where is my origin over here? It is over here, n is equal to 0. Now, y of 0 is equal to summation k going from 0 to 3, that is 0, 1, 2, 3. So, now my k is going from 0 to 3, x of k, h of minus k. Okay. Now, you put the values of k. When I put the value of k, what I will get? I will get x of 0 first, h of minus 1 plus x of 1, h of minus 2 plus x of 2, h of minus 3 plus x is equal to 3, h of minus 4, sorry, minus 3. So, it is really difficult to visualize this y of 0 or really difficult to analyze this equation. So, let us use one more method which we called as a graphical method. This will ease our life. So, let us choose to go with graphical method. Now, with the graphical method, we plot x of n first. So, I say that step 1, plot x of n. X of n or x of k is 1, 2, 3, 4. So, I write it 1, 2, 3 and 4. So, it is 0, 1, 2, 3, it is 1, 2, 3 and 4. Step 2 is to plot h of n. So, it comes as 4, then look after that you actually indentedly bring it one after the other. So, 1, 4, at n is equal to 1 is also 4, then we have 3 and then we have 2. This is 4, 4, 3, 2. for n is equal to 0, 1, 2, 3. Step 3, plot h of minus n. Now, to plot h of minus n, I have to indent it clearly. This is my h of minus n. Now, I have to keep 4 as it is, mirror imaging. I will bring this on the side, so it becomes 4 this side. Then I bring 3 this side, so it becomes 3 on this side, and this becomes 2 on this side. So, now this is 2, 3, 4, 4, nothing on this side. This is n, this is my n. Okay. So, what I did, step 1, I have plotted x of n, step 2, I have plotted h of n, and step 3, I have plotted h of minus n. Now, in step 4, what I will be doing is, I will be multiplying this signal with this signal. Straightforward sample to sample multiplication. If I multiply this signal with this signal, what you can see is 1 is getting overlapped with 4, 2 is multiplied by 0, 3 is also multiplied by 0, and 4 is also multiplied by 0. So, every sample we have to overlay on each other and see how it multiplies. So, 1 overlays with 4, so multiplication gives answer as 4, 2 overlays with 0, so answer is 0, 3 overlays with 0, so answer becomes 0, 4 overlays with 0, so answer is 0. Similarly, if I see on the negative side of n, then this 4 overlays with 0, this 3 overlays with 0, and 2 overlays with this 0. So, answer comes as there is only 2 overlays, that is at n is equal to 0, which is this point. So, y of 0, because we are looking at n is equal to 0, y of 0 comes as x of 0 multiplied by h of 0, which is nothing but 1 multiplied by 4, which is equal to 4. So, we got y of 0 as answer as 4. Now, if I go for n is equal to 1, my equation writes as y of 1, which is equal to summation k goes from 0 to 3 x of k, I write like this, h of, we would written n minus k. So, h of, I write it minus k plus 1. This plus 1 is because now my n is equal to 1. Here we have n is equal to 1. So, now what it shows is, I am shifting h of k, rather shifting minus h of k plus 1. Plus 1 is called as delaying of signal, because we are shifting mirror signal. Plus 1 indicates it is a delay of signal. Why? Because we are shifting a minus k or mirrored signal. So, all the properties of signal shifting will be converted or changed because I am shifting a mirrored signal. Therefore, I get, now I have to shift the h of minus k by 1, I have to delay. Delaying process is shifting the signal to right. Advancing of a signal is to shift to left. So, I will shift it to right or shift it to left. Delay shifting right, advance shifting left. So, let us go back to our graphical method and shift. I will draw only x of n because that is required for multiplication. X of n is 1, 2, 3, 4. So, 1, 2, 3, 4, n is equal to 0, 1, 2, 3. Okay. Now, I will draw h of minus n plus 1. So, h of minus n plus 1 is shifting the signal to right. So, initially my signal was 4, 4, 3, 2. So, I will draw in dotted the initial signal, that is h of minus n. So, minus n was in dotted, I will draw, this is 4, 4, 3, 2. So, I have 4, 4, 3, 2 as my h of minus n. I will shift that signal by a value of 1. So, when I shift that signal, the first instant, this is my n is equal to 0, this is n is equal to minus 1, this is n is equal to minus 2, and this is n is equal to minus 3. Now, I have to shift that signal by 1 value. So, my 4 will be now actually coming on 1. So, my new signal comes like, this is my 4 which is shifted by 1. On n is equal to 0, my n is equal to minus 1 signal will get shifted and it will come as 4 over here. Then I have 3 which will be coming at n is equal to minus 1. So, I will just draw it beside it. This is 3 and then I will get the last sample as 2. This will be my 2. So, I got 4, 4, 3, 2. So, by shifting by one sample value of plus 1, I got all the samples shifted on the right of the y axis. Now, let us multiply again whatever overlaps, you have to see the overlaps. So, the overlap over here is the sample at n is equal to 0 overlaps with n is equal to 0 over here, and now a new sample at n is equal to 1 also overlaps. Whereas, if you see minus 1 overlaps with 0, minus 2 overlaps with 0 and minus 3 also overlaps with 0. Your 2 overlaps with 0 and 4 overlaps with 0. So, this 2 samples will be going to 0 and this 2 samples will also convert to 0. Only the samples that will result is this 2. So, I will have y of 1 as 1 into 4 which is 4 and I have 2 into 4 which is 8. What should I put in between them? So, if you remember the formula says it is to be summation. So, summation means we have to add them. So, when we add it, we get 4 plus 8 which is 12. So, y of 1 is equal to 12. Then, similarly, if I shift this signal once more, I will get y of 2. Y of 2 will be equal to summation k going from 0 to 3 x of k h of minus k plus 2. That means now I will be delaying the signal by 2. Why? Because why there is a delay? Because I am using which signal? A mirror signal. If there was no mirror, then I would have advanced this signal instead of delaying the signal. So, I will get x of n as 1, 2, 3 and 4, and then I will be going about now as h of minus n plus 2. So, if we do similarly, previously for h of minus n I had 4 over here, I also had a 4 over here. So, this was 4, 4 and then I was having 3 over here and I was having 2 over here. Okay. So, this is the previous signal which was n minus n plus 1. Now, I will shift that signal once more and I will draw it with red. So, red curve will show that there is a shift of 2 and blue curve shows that is a shift of 1. So I show it as now this signal will further shift on right, and we will get a new sample over here as 4. Then this sample will take this position and it will comes 4 again. This will take its value and it becomes 3, and this will get shifted and gets the value of 2. So the red curves show that is a shift of, so this signals shows a shift of h of minus n plus 2, whereas blue shows h of minus n plus 1. Therefore, now see the overlap with the red and black. 2 overlapped with 0 will go to 0, 3 overlapped with 1 now, 4 overlapped with 2, and 4 overlapped with 3. So I have 2 overlapped with 1, it's 2. Now we have 2 into 0, then we have 3 into 1, then we have 4 into 2, and we have 4 into 3. And in between each multiplication we have addition. So 2 into 0 becomes 0. So y of 2 we are going ahead with. So I'll write only 3 plus 8 plus 12. So this is my new y of 2. Okay. Similarly, if we go ahead, then for now y is equal to 3, what you will do? For y is equal to 3, you will shift this signal once more. So 4 will come, this 4 will get overlapped with now new 4, 3 will get overlapped with 4, 2 will overlap with 3, and 1 will overlap with 2. And this process will go on till this sample moves out of 4. So I am going on shifting till this 2 moves out this frame by after 4, then every overlap will give me 0. Therefore, I can conclude with this that y of n will have L plus m minus 1 samples. Now where is this L and where is this m? Where L is the number of samples in x of n, m is the number of samples in h of n, and minus 1. So y of n will be equal to L plus m minus 1 number of samples, where y of n we normally write or denote by capital N. Capital N is the number of samples in y of n. So the formula comes as n is equal to L plus m minus 1. So with the previous example where my x of n was having value as 1, 2, 3, 4, that means 4 samples, h of n was 4, 4, 3, 2, which is also 4 samples, minus 1 will give n is equal to 7. Okay. With this in mind, when n is equal to 7, we started y of n with 0. So y of n will have first sample at n is equal to 0, then at n is equal to 1, 2, 3, 4 and so on till 6 and not 7. Because I started with n is equal to 0, so I will go up till 6 and not 7. So 7 should not be included because 7 will be all zeros. So we should go from 0 to 6. So whenever I convolve using this method or any method, I will always get L plus m minus 1 samples. So to conclude this process, first we have seen that we have used linear convolution and convolved aperiodic signals. Second, there are n is equal to L plus m minus 1 samples in the output signal. So there are basically two conclusions that we have drawn, that if we have our periodic signals, then we will go with linear convolution, and the total number of samples that I will get in the output are L plus M minus 1, which we denote by capital N. So in the previous example it was 0 to 6. We found till 2. Similarly, you can find for 3, 4, 5 and 6 by shifting y of n 1 bit every time and overlapping and multiplying. Now, it is really tedious that we shift every time and do this multiplication and drawing the diagram again and again. So there is one more method which we called as tabular method, which also gives the same result as that of graphical method or the formula based method. So in tabular method, what we do is we create a table, not likely to be matrix but a table, whose one side I will put x of n. Let us say that I put x of n over here, and the other side I put h of n like this. So my h of n numbers will go like this, x of n numbers will go like this. So my x of n is 1, 2, 3, 4, and h of n is 4, 4, 3, 2. Let us extend. Then I will multiply as 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. Then 4 1s are 4, 4 2s are 8, 12, 16. You see that I am multiplying this way. This is the order of multiplication, row and column, row and column. So 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 2 1s are 2, 4, 6, 8. Okay. Now you have to add, because multiplication is done. We have seen that convolution we are performing two basic operations. One is multiplication and one is addition. So multiplication is done. Now we have to go for addition. For addition you have to go diagonally, like this element, then this 2 element, then this 3 elements, then this 4 elements, again 3 elements, 2 element and 1 element. So I get my y of n as equals to 4, then 4 8 12, then 15 8 23, then 12 12 24 and 2 26, then 29, then 18 and then 8. So how many samples I am getting? 1 2 3 4 5 6 7 samples. But if I write in terms of n, then n will start from 0, 1, 2, 3, 4, 5, 6. So n will go from 0 to 6, whereas my total number of samples are 7. So this method is normally used to cross verify or cross check the answers that you have got using graphical method. So this is alternative method to the graphical method of finding a convolution.